Hi, I'm Stacey. I'm a hardware design engineer and I've been developing for FPGAs for over 12 years. I hope you don't mind the background. Whatever. I don't know what I'm doing. This is my very first YouTube video. You must excuse me. I'm just here because I want to talk to beginners about some of the things that I've seen that people do when they're first learning these languages, and it can be quite a steep learning curve, especially if you're coming from a programming background and you're used to using programming techniques like for loops in specific ways, and they don't really work those ways in System Verilog and VHDL. And so I thought I would contribute my YouTube video to the world so that some people can learn a few things about what I think about as a professional as I'm developing in these languages. So I've got my PC here, and we're going to be going through the HDLBits website, the exercises that they have. I'm not affiliated with them. It's just a really nice website for beginners to learn Verilog without having to use hardware or software on their PC. It can be done in your browser, and it's a really nice way to quickly get into the nitty-gritty of learning Verilog without too much setup. And those tools and hardware can be quite a bit of a learning curve, and so this kind of skips over those kinds of problems. So I'm going to get into it, and we will switch the view if I can figure out how to do that. I'm also going to be putting a link in the description to the website, and I recommend that you give these a try first. If you haven't, give them a try, because I'm going to be showing you all the answers. So if you want to try it all yourself first, I recommend going and trying to do them first before you watch this video if you have any interest. And then some of them are really simple, but I'm going to be talking about some key points that I think about when we go through these things. Cool. Okay, so I've got HDLBits open on my PC, and I'm going to go to the first problem. Click. And we're going to scroll down. So the number one thing that I think about, and that is I'm not programming. So VHDL and System Verilog are not normal programming languages. I know it's tempting to think that they're normal programming languages because you are typing into a text editor and hitting go and it's doing something and showing you an output on your PC. But the reality is that we are describing a circuit. And so that is demonstrated from this very first example. We could look at this and be like, oh, 1 is a variable. I have a variable and it's called 1, and now I'm going to give it a value. And the reality is actually what 1 is actually a signal. It's not a variable. And so when we're saying, okay, this signal is going to be driven by a high value. So this is the equivalent of taking a wire and taping the word 1, the name 1 to that wire, and say, this is my wire and it's called 1. And I am going to be putting a high voltage on that wire. I'm going to be connecting it up to a battery. And so that is what's physically happening in the FPGA when we type the statement. So I'm going to be typing 1'B1. So this is a syntax that's going to be familiar to some people if they already know Verilog, but for everyone else who's like, what the heck does that mean? We'll just go through it. So 1 is the number of bits. Okay, and then we have an apostrophe, and then we have, which is always there, B for binary, and then we have 1, that's the actual value, is 1. Okay, and so this number is binary. If we had an H, it would be hexadecimal. If it was a D, it would be decimal. So those are the different values that you can put in for the base. So it's always 1 is the number of bits. But I recommend that you always specify the number of bits that you're using. Okay, let's hit go, submit. So this is the Quartus compiler. I recognize it. You see, even says show Quartus messages. So I recognize this as Quartus, and we're good. See? So it shows me a simulation output, which is what we want. So now we can go to the next one. 0. So this next one is going to be exactly the same exercise. It just wants us to put a sign in. So again, this is not a variable. This is a wire. This is a physical wire. I am making a physical wire and I'm calling it 0. 0. I'm taking my duct tape and I'm writing 0 on my wire and I'm putting it, I'm writing 0 on my tape and I'm putting it on my wire and I'm saying, this is my wire and it's called 0. And then I'm driving it with the value of voltage, which in this case is ground, or 0 volts. 1 apostrophe B 0, like that, okay? So I always try to make sure that I specify how many bits I'm working with, and I use this syntax as much as possible. Submit. Success. Wait, did I see? Yes, it says success. I was second guessing myself. Like, yes. Okay, so now, if we want to drive one signal with another, we have one input in and another input out. So we're just going to go assign out to be equal to be driven by in, just like that. Submit. So you can see that I am using different terminology for the words and the variables, because they're not variables, they're wires. So we're saying driven by, and we are saying we're using the number of bits. Good. Next up, we've got 4 wires. So one of the other things that I'm going to talk about is the fact that every output needs to be driven in one place. So I can go assign W is driven by, so in this case W is driven by A. Assign X is driven by B. But I can't go assign X is driven by C, because that means that X is driven in 2 different places, and you can't do that. So we need to do WXY is driven by B. So you can do this. You can have 2 outputs driven by 1 input, but you can't have each output being driven in 2 different places. The other thing that I will also point out is that this order doesn't matter. Okay, in a normal programming language, the order of the statements in the file matters. You want the one statement to execute first, and then the next statement executes, and then the next statement executes. In this syntax, I can put these statements in any order. They all happen at exactly the same time. Assign Z is driven by C. So these are all wires. So I'm saying I want to connect wire W up with input A, wire B, wire X, and so on. Submit. Good. I'm looking at this like I'm worried it's not going to work. I mean, I could mess up the syntax, but yeah, it worked. Okay, dot gate. Assign out is driven by not in. So what does this mean? This is a binary inversion. So this means take all the bits and flip them. So this is not a logical negation. This is a binary negation for the programmers out there. This just means take every single bit in my bit string, no matter how long it is, and just flip them all over. That's all we're doing. And that's the tilde. Submit. And gate. So when we want to combine wires, we have to specify how we want them to be combined. If we want to combine 2 signals, we need to specify how we want them to be combined. So in this case, we're using an AND gate. In Verilog, the syntax is C style syntax, which is extremely common, but also can be deceiving, because then you get deceived into thinking that you're coding in a programming language when you are not. We're describing a circuit. So we're going to go out is driven by, assign. Out is driven by A, and, which is an ampersand, B. So there are some things that people mess up here. First off, what happens if A and B are different lengths? What if I have A being 16 bits and B being 15 bits? Where does that other bit go? What if my output is 20 bits? Then what? This is why it's so important that you keep track of how long your signals are, right? Verilog lets you get away with doing really, really weird stuff. You can get away with connecting a 6-bit signal to an 8-bit signal, or ANDing a 6 and an 8 and driving a 20-bit signal, and it'll just be like, sure, cool, I'll do that. And you know what? It's bad. It's very, very bad, because it means that you're making, it doesn't tell you. It actually does. It tells you in the compiler warnings, but people don't look at the compiler warnings. There's so many compiler warnings. People don't look at the compiler warnings. So I recommend that you keep track of every single signal and you read those compiler warnings. This is why I recommend that when you're driving constants, you use specific constant lengths. It just forces your brain to think about it. VHDL is better because VHDL won't let you get away with this. VHDL will say, no. You tell me, you figure those signals out so that they're the right lengths. You get that sorted. I ain't dealing with this. So VHDL is better for beginners in that it forces you to use your brain and think about your signal lengths. In Verilog, you can just throw whatever you want at it and it'll just be like, yeah, that's no problem. Okay, so let me tell you about what Verilog's going to do if you try and AND two signals that are different lengths. It will just make it whatever the output is, and it'll extend it or truncate it. So if you are driving a 20-bit signal, it's just going to AND, it's just going to pad to 20 and AND. So if you have 6 and 4, it's just going to put zeros on the end. So if you're working with negative numbers, if you're using 2's complement, it's not going to work. It's going to break because it's padding zeros, and 2's complement requires padding of 1s if it's a negative number. So you want to make sure that if you're working with negative numbers, you're explicitly extending your signal lengths or you're keeping track. So you can't let Verilog pad your numbers for you and just be like, oh, we're cool, because Verilog is not going to assign extend nicely for you. So Verilog's just going to add zeros in the most significant places until it gets to the length that it's driving, or it's going to truncate. If you try and drive a 20-bit signal with a 24-bit signal, it's just going to be like, we don't need those 4 bits at the top, bye-bye, and you're going to get problems. So just be aware that Verilog's going to do that, and it's going to put it in the compiler warnings, and it's going to pretend like all is cool, and it's not going to behave nicely. Okay, so this is why I'm doing this. Like, you would think A and B out is driven by A and B. Can't be that bad. Can't be that complicated. Well, you have to keep on keeping on. You have to make sure you know what you're doing. Okay, let's go. My rant is over. Submit. That's my 2 cents. Because people do this. And this is why VHDL is better for beginners. Yes, it's a horrible language because it's more verbose. And it really takes longer to code. But for beginners, it's great. I learned VHDL first, and I'm so glad I did. Okay. NOR gate. Yes, we have something else to talk about. And I think this is going to be the last one because I'm seeing the time, and I don't want to rant for like days. So, I'm going to offer another key point here. Is this the one that I wanted to do a key point here? What's this, a NOR gate? Yes. Okay, this is an NOR gate, right? One of the other things that I want to talk about, and then I'm going to be done, and then I'll call it like a 20-minute video or whatever. It is very tempting, you know, especially when you're learning a programming language and you learn a new technique and you learn a nice shortcut or a bit twiddle. There's really nice bit twiddles online if you look at the bit twiddles. It's really, really tempting to kind of show off what you know, right? Oh yeah, I know that there's this little trick where we do this little bit twiddle and then all the bits come out at the end of the day and it works. Nice. Okay. The problem is, if someone else comes along and they don't know what the heck you're doing and they don't know what bit twiddle you're doing and they don't understand what you're doing, then it's just going to be super confusing. Or maybe you come back and it's like 2 years later and you're coming back to code that you wrote 2 years ago and you're like, wait, now what does this weird bit twiddle do again? So my number one recommendation, apart from remembering that you're not programming, is to code as simply as you and explicitly as you possibly can. If it's more lines of code, if it's a bit longer, if it looks simple, it doesn't matter. You want to prioritize clarity in your code over anything else. Don't try and be fancy. Don't try and use weird bit twiddles. Just explicitly code clearly what you want. So there are weird ways that I could do an OR gate if I had weird syntax, but what I'm going to be doing is I'm going to be coding this, and obviously, like, this is a very simple example, but if you had some weird binary bit Carno map implementation that you want to like go crazy on, just be simple about it, make it as human readable as possible, and let the synthesis tool do all the work. The synthesis tool's job is to take your code and do all the binary things, right? So just don't try and be fancy with what you're doing. Just do it as simply as, if your brain is thinking about something in a specific way, then code it like that. So I'm literally going to make this assign out is driven by, it's an exclusive NOR gate. It's not an exclusive NOR gate, it's just a NOR gate. Not A or B. Literally, that's it. There may be other syntax, there may be other options, I don't even remember or care, because in my mind, a NOR gate is not or. So I'm just going to code not or. And if anyone comes along and they looks at this, they're just going to be like, it's a NOR gate, right? And if there are fancy ways of implementing that in the synthesis tool, or there's weird things, I don't care. It's clear, it's simple. You don't have to be fancy. You don't have to like show off your skills. You just code it the way you think about it, because then when other people come along, it's clear. And when you come along in 10 years' time, it's clear. So that's my number two trick. Those are like the most important things that I think about. If I'm talking to someone, I've interviewed people to hire them for programming in these languages, and these are the two things that I'm thinking about. Number one, are you thinking about this from a hardware perspective and not a programming perspective? And number two, you're coding as simply as possible. No frills, no fancy bit twiddles, no trying to be impressive with high level thinking, just code simply. Okay, submit. And I think I'm going to stop there because that's 20 minutes and I don't think I should release on the world me talking for too much longer. So I hope that you liked my very first YouTube video. Yay! I did it! I survived! It didn't take that long. I don't even think I have to edit it that much. Hopefully not. Hopefully I didn't talk too much. I do tend to run on and be verbose. You could give me feedback. If there's anything specific you want to talk about, then you can ask me questions in the comments, you know, if you want to see stuff. So I'm going to, this is done. It was successful. I'm glad. And I'm going to sign off now and say thank you very much for watching my first YouTube video, and I hope that it's not super high tech, it's not fancy, but I just wanted to get across the information that I thought was important for beginners, and I really hope that this can be helpful. And I really welcome your feedback, and I'll make some more of these if there's more interest. And I'm not even looking at the right place on my phone. I'm supposed to be looking there. Okay.